This video is on Class 10 Mathematics, and today's topic of discussion is Chapter 5 Quadratic Equation in One Variable. If an equation is written in the form of ax squared plus bx plus c equals to 0, that is known as a quadratic equation. Here, a, b, and c are known variables, whereas x is an unknown variable. That means we have to solve the equation in order to find the value of x. Also, a, which is written along with x squared, the value of a should not be equal to 0. This is the standard form of quadratic equation. Now moving on to exercise 5.1. Question number 1. Check whether the following are quadratic equation. So number 1 question is root 3x squared minus 2x plus 3 by 5 equals to 0. We just have to check whether this is in the form of ax squared plus bx plus c equals to 0. And yes, it is in the same form. We have x squared, we have x, and we have a constant 3 by 5. Hence, we can say that the given equation is a quadratic equation. Next, number 3. X minus 3 whole cube plus 5 equals to x cube plus 7x squared minus 1. Now, let us solve it further. So, on the left hand side, we have x minus 3 whole cube, for which we can write x cube minus 3 cube, that is 27, minus 3ab, that is 3 into x into 3, that is 9x, into x minus 3. In the right hand side, we'll write the same thing, that is x cube plus 7x squared minus 1. Now solving it further, x cube minus 27 minus, now 9x into x will have minus 9x squared, and minus 9x into minus 3 is plus 27x. That equals to x cube plus 7x squared minus 1. Now, bringing all the left-hand side variables to the right-hand side, x cube and x cube will get cancelled. So, we'll have 7x squared plus 9x squared minus 27x plus 27 minus 1 equal to 0. Hence, the resultant equation is 16x squared minus 27x plus 26 equals to 0. This is also in the form of ax squared plus bx plus c equals to 0. Hence, the given equation is a quadratic equation. Question number 2. Determine whether the given numbers are roots of the given equations or not. So here, they have given the roots of the equation. In this question, we have 1 and minus 1. Now, putting the value of x to be 1 and minus 1, we'll check whether the equation is fulfilling or not. That means the result of the equation is equal to 0 or not. If the result of the equation is equal to 0, then we can say these are the roots of the equation. If it is not equal to 0, then they are not the roots of the given equation. So we are starting with putting the value of x equals to 1. So 1 square minus 1 plus 1 equals to 1, which is not equal to 0. Again, putting the value of x equals to minus 1, that is minus 1 whole square, that is plus 1, minus minus 1, again it will turn to plus 1, plus 1. That is, in the left hand side we are getting 3, which is not equal to 0. Hence, we can see that 1 and minus 1 are not the roots of the given equation, because the result of both the equation after putting the value of x to be 1 and minus 1 is not equal to 0. Next, number 4, 6x squared minus x minus 2 equals to 0. Here, the roots are given as minus half and 2 by 3. Now, putting the value of x equals to minus half, we have 6 into minus half whole square minus half in the bracket minus 2. This will give us 6 into 1 by 4 plus half minus 2. Now further solving it, we'll get in the numerator we'll get 4 minus 4 divided by 2, which is equals to 0. Again, putting the value of x equals to 2 by 3, that is 6 into 2 by 3 whole square, minus 2 by 3 minus 2. So we'll get 6 into 4 by 9 minus 2 by 3 minus 2. If we further solve it, we'll get 8 minus 8, which is 0, divided by 3. So that is also equal to 0. Hence, after putting the value of x equals to minus half and 2 by 3, the result of the equation is equals to 0. Hence, we can say that both minus half and 2 by 3 are roots of the given equation. Question number 4. Number 1. If minus half is a solution of the given equation, 3x squared plus 2kx minus 3 equal to 0, find the value of k. So here minus half is the solution of the equation, that means it is the root of the equation. So if we put the value of x equals to minus half, that is going to fulfill the equation or satisfy the equation. So let us put minus half in the given equation in place of x. So we'll have 3 into minus half whole square plus 2k into minus half minus 3 equals to 0. So this will give us 3 into 1 by 4, that is 3 by 4. Here 2 and 2 will get cancelled. So we'll have minus k minus 3 equals to 0. So keeping k on the left hand side, that is minus k equals to, and we'll bring the numbers on the right hand side. So we'll have plus 3 minus 3 by 4. So minus k is equals to, taking 4 as the LCM, we'll have 12 minus 3 in the numerator. So minus k is equal to 9 by 4. Now multiplying minus or negative sign on both sides, we'll have k equals to minus 9 by 4. Now question number 5. Number 2. If a is a root of the given equation x square minus a plus bx plus k equals to 0, find the value of k. So again, since a is the root of the equation, so we can, if we put x equals to a in the given equation, the equation will satisfy. So instead of ax, we'll put a in the equation, that is a square minus a plus b into a plus k equals to 0. This will give us a square minus a into a, that is a square, and minus b into a, that is minus ab, plus k equals to 0. So here a square and a square will get cancelled, and we can write k equals to, will bring the ab on the right hand side. So therefore the value of k will be equal to ab. Next, question number 6. If 2 by 3 and minus 3 are the roots of the equation px square plus 7x plus q equals to 0, find the value of p and q. Here we have to find two variables from the given equation. So, and it is say, and two roots are given. So what we'll do is, we will put the value of x to be 2 by 3 once, and again we'll put the value of x to be minus 3 and find the two equations and solve them. So first we'll put the value of x to be 2 by 3. This will give us p into 2 by 3 whole square plus 7 into 2 by 3 plus q equals to 0. From this we'll get 4 by 9p plus 14 by 3 plus q equals to 0. Now taking the LCM to be 9, we'll get 4p plus 42 plus 9q equals to 0. So 9 multiplied by 0 will become 0. So in the left hand side we'll have 4p plus 42 plus 9q equals to 0. Now leaving the variables on the other side, just bring the number on the right hand side. So 4p plus 9q equals to minus 42 is the first equation. Now again putting the value of x to be minus 3. Let us see the equation. that is p into minus 3 whole square plus 7 into minus 3 plus q equals to 0. That is equals to 9p minus 21 plus q equals to 0. Now keep the two variables p and q on the left hand side and we'll bring the number on the right hand side. So this will give us 9p plus q equals to 21. This is the second equation. Now see, in the simultaneous equation we know that we have to cancel one of the variables. So in order to make one of the variables equal, that is, here in the first equation we have 9q, in the second equation we have only q. So multiplying the second equation by 9 we can get 9q. So multiplying equation 2 by 9 will get 81p plus 9q equals to 189. Now subtracting equation 1 from equation 3, that is 81p plus 9q equals to 189. 9p plus 9q, 4p plus 9q equals to minus 42. So 9q and 9q is getting cancelled. 81p minus 4p will get 77p, and here 189 minus this minus 42 will become plus 42, hence we'll get 231. Therefore p equals to 231 divided by 77, which is equal to 3. Now putting the value of p equals to 3 in equation 2, we'll get q equals to 21 minus 9 into 3, that is 9p it was. So instead of p we have written 3. So q equals to 21 minus 27. Therefore the value of q equals to minus 6. That's all for today. Thank you.